this is section 2.4. We're going to work on writing linear equations. And so one of the ways we can do that is by looking at the graph and write the equation. So the easiest one to write from the graph is slope-intercept form. So I just look at the graph and I want to pick out what is b and what is m. So b is that point where it's crossing the y-axis. So here this is 1, positive 1 on the y-axis. And then the slope, I just need to look at rise and run. So I have 2 nice points marked here for me. So to get from one point to the other, and we always start with the leftmost point. So from here, I go down 3 and over 4. So down 3 makes it a -3, and then 4 is the horizontal change. So remember, it's always the change in y over the change in x. So my slope is -3/4. So the equation is y equals -3/4 x plus 1. And that would be our equation in slope-intercept form. All right, we can do a very similar thing here with a table. Okay, so one of the things we need to find is the slope. So I can look at change in y over change in x. I can see right now that these numbers are decreasing by differing amounts, it looks like. Well, I'll just show you a couple ways. So one thing we're going to do here is I'm going to pick 2 points, and I'm going to pick 2 that are like nicer just because I don't want to deal with the decimals. And I'm going to find my slope. So from 2 points, I can use my slope formula. I'm going to make this my x1 and y1 and my x2 and y2. So slope formula is y2 minus y1. So I have 1 minus -5 over x2 minus x1. So 8 minus -8. So simplify here, the double negative is going to make it positive, so we get 1 plus 5 is 6, and 8 plus 8 is 16. If I reduce that, I can divide both those by 2 and get 3/8. So my slope is 3/8. So one of the forms, since they don't specify which form to use, we can choose whichever one is the most convenient. So for this one, I don't know the y-intercept because none of these give me a point where x is 0. So I'm just going to pick any point, and I'm going to use point slope form. So point slope form, as a reminder, is y minus y1 equals the slope times x minus x1. So I just need the slope and 1 point. So I, again, can pick whichever point I want. I'm going to pick the 8, 1 point. And so I'm going to plug in 1 for the y-coordinate. My slope I already found is 3/8. And then x for the x-coordinate here is 8. And I can leave it just like that because they don't specify that it has to be in slope-intercept form. I can just stop there at point slope form. So we just need the slope and a point. We had to do a little work to find the slope first, but I have lots of points to choose from here. Okay, here they want me to write a line with a slope of 1/2, and it has to pass through the point -8/3. So again, this is not the y-intercept because it's not 0 for the x. So point slope form is the one we just practiced. This one is really simple. We have y minus the y-coordinate, which is 3, equals the slope times x minus the x-coordinate. And anytime I do have that double negative here, guys, go ahead and write it as plus. That's just a little more simplified, having less signs to work with. That's done. Point slope. Now we're also asked to put it in slope-intercept form. So I'm going to actually start with what I have right here. And slope-intercept form, I just need to get rid of the parentheses and get y by itself. So I'm going to distribute this 1/2. So I have 1/2 x plus 4, half of 8 is 4, and then get y by itself. So I just add 3 to both sides. So I have y equals 1/2 x plus 7. And that is in slope-intercept form. So these are representing the same line, just 2 different ways to write it. Okay, a line that contains points -1, 12, and 5, -6. So again, I need a point and I need slope if I'm going to use point slope form. So I don't know the slope, so again, I have to start by finding that. So here's my first point, so I'm going to call that x1, y1, x2, y2 for my second point. So slope is y2 minus y1, so -6 minus 12. Over 5 minus -1. Okay, so I get -6 minus 12 is -18. 5 plus 1 is 6. So my slope is -3. And then point slope, I can choose either point. It doesn't matter. I'm just going to use the first one. So y minus the y-coordinate equals the slope times x minus the x coordinate. And again, I'm just going to write that as plus. So this would be point slope form. I could distribute the -3 and then add 12 if I needed it in slope intercept form. All right, this is another way we can see 2 points. Remember, this is the input for function notation, and this is the output. So another way to think about that, input is the x and output is the y. So this has the point 3, 3. This one has the point -1, 4. So that's just another way to see points written using function notation. So I can just use the slope formula again. So I'm going to do 4 minus 3 over -1 minus 3. So I get 1 over -4. So -1/4 is my slope. For writing the equation, I have y minus the y coordinate. It does not matter which point I pick. I'm going to choose the -1/4. So I'm going to do y minus 4 equals the slope times x minus x1. So again, change that to plus if it's minus and negative. And then that is in point slope form. All right. Okay, this is a little bit of geometry review here, you guys. We talked about parallel and perpendicular lines. It's important to remember that parallel lines will always have the same slope, but they'll have different y-intercepts. Perpendicular lines are going to have slopes that are opposite reciprocals. Okay, so I'm going to give an example of that here. So if I have a slope that is 2/3, the symbol for perpendicular is this upside down T, so I'm going to use that. So if this is my slope for perpendicular, would be opposite. So what that means is opposite sign. So if this one's positive, the opposite would be negative. And the reciprocal is just a flipped fraction. So if this is 2/3, I'm going to flip it and make it 3/2. So if those are the slopes of two different lines, they are perpendicular to each other because they're opposite reciprocals. Okay, so let's go back to parallel lines. Write the equation of a line parallel to this one that passes through -1, 3. So the first thing I want to identify is what is the slope. So the slope of this line, it's in slope intercept form, so my slope is just -2. So I need to make sure I have that same slope, and I want it to go through this point, so I have enough to write the equation of a line. We have slope and point, so I'm going to use point slope form. So y minus y1, the y coordinate is 3. Slope we know has to be -2, and then x minus -1 will turn to x plus 1. Okay, write the equation of a line that is perpendicular to this one and passes through the point 4, 3. So if my slope here is -4, I need its opposite reciprocal. So that means the perpendicular slope is going to be positive, and I can think about this as 4/1, so flipped would be 1/4. So those are opposite reciprocals of each other. This is the slope I need for the line to be perpendicular. So the point I'm using is 4, 3, so y minus 3. Slope is 1/4, and then x minus the x coordinate, 4. Okay, so how do we look at two different lines equation and tell if they're perpendicular, parallel, or neither? Okay, so well, we can look at these here and evaluate, but it's probably easier to convert them to slope intercept form. So I'm going to rearrange these and get y by itself. So this one, we have -3x plus 4y equals 15. So I'm going to go ahead and add the x's so that I'm one step closer to getting y by itself. So I have 4y equals, I have 3x and positive 15. I'm intentionally writing the x's first so it's in mx plus b form. Now I need to come through and divide everything by 4. So that means I'm dividing 3 by 4, so 3/4 is the slope. And then I also need to divide 15 by 4. Okay, so that's slope intercept form. Okay, so that's the first line. We're going to do exactly the same thing on the second one. So I have 9x minus 12y equals 24. Subtract 9x. So I have -12y equals -9x plus 24. Divide everything by -12. So I get y equals positive 9/12 x minus 2. And then I can reduce both of those divide by 3. So I've got y equals 3/4 x minus 2. So now I'm going to compare these. So if they are parallel, they have to have the same slope, perpendicular opposite reciprocal slopes, and if they don't have either of those, then it's neither. Well, I see from rearranging those that I do get the same slope. So the lines are parallel. All right, that's our last example for this video. Thanks for watching.